All right, so imaginary numbers to start with is only for numbers that have an even index. That index here must be even. And that's because it's okay to take the cubed root of -8. So underneath here is if I have -9, -81. I'm not going to do 1 to the 8th because that, well, why not? -256. So the order of operations always takes out the imaginary number first. So in essence, what you do is, this is a process, the step that I want you to go ahead and think. Think of this as -1 times 9. Think of this as -1 times 81. Or this as -1 times 256. So this -1, it always comes out, and it comes out as I. And once you do that step, and it's I square root of 9, or I square root of 81, or I, fourth root and the 8th root of 256. The square root of 9 is just equal to 3. So this becomes 3i. The fourth root of 81 is 9. So that also just becomes 3i. And the 8th root of 256 is 2, so that's 2i. So those would be your 3 answers for those questions. As that's the same thing as taking -1 times the square root of 5, so that's just I times the square root of 5. Now, where we run into problems is if we have also operations put inside there. So if I have something that looks like the square root of -2 times the square root of -5, we must follow the order of operations. So the first step always is take out I. And when I do that, what does that leave me with for the 2? That is going to be I comes on the outside, then the square root of 2. And I multiply that, and over here again, that negative brings out the I on the outside, but the square root of 5 stays on the inside. So now I'm back to the rule where I multiply the outside together, and then I multiply the inside together. And that gives me I squared times the square root of 10. Now, this brings up a special property here. So if I is equal to the square root of -1, then I squared will always equal -1. So that's just it. No matter what you have, that's what we're going through and doing. And this is the whole purpose of what I is about. Now I could keep going with this, but for this question, let's go ahead and finish it. So that would mean I squared, I replace it with -1. So that's -1 square root of 10. So think of I, and this is not on your test. This is just some information about I. So this is my real dimension. This is my imaginary dimension. So imagine if I take my number here, 5. If I go ahead and take 5 and multiply it times I, now I'm up here at 5I. Now what happens, and again, this dimension, this is my positive reals, this would be my negative real numbers, this is my positive I numbers, and this down here is my negative I numbers. So this is the way this works with rotation. And it's just something kind of cool, and I want to just show it to you. So if I have and take that 5I, which is where I am right now, and multiply it times another I get 5I squared. And we just said what that is equal to, right? I squared gets replaced with a -1. So now that is equal to -5. So where am I? Now I'm back over here at -5. If I take that -5 and multiply it times I again, that gives me a -5I. And now I'm down here. And if I do this one more time, and I take that -5I and multiply it times I one more time, I get -5 times I squared, and I squared is -1. Well, guess what? That's -5 times a -1, which is a +5. So now I'm back to where I started with. So this idea of imaginary numbers is really just rotational. It's rotational. I start here at 5. I multiply times I. I'm at 5I. I multiply times I again. I'm down here at -5. Then -5I, and back up to 5. And that piece just keeps repeating over and over again. So with this question, remember the order of operations, the first thing you always do is find I. It's really, really important. So now when I do this, I have the square root of 81 over I square root of 6. Now, because both of the 81 and the 6, both of those are under the radical, I want to go ahead and just reduce those because it's going to make life a little bit easier for us to do that. And it's only because they're both underneath the radical. So both 81 and 6 are divisible by 3. So that gives me 27 over I square root of 2. Now, I have to rationalize this, but by the same way I can't have a square root in the denominator, you also cannot have an I in the denominator. So what you want to do is multiply the top and bottom by I square root of 2. But it's really important, and I mean this, order of operations, always turn something into an I if there's ever a negative underneath a square root. So now when I go through and do that, I'm left with 2 times 27 because they're both underneath the radical, which gives me the square root of 54. The I is outside the radical, so that I comes in front. And then in the denominator, again, I multiply what's outside the radical, so I have I times I, which gives me I squared, and I'm going to deal with that in a second. I don't want to cancel it out. And then I also have what's underneath the radical as the square root of 2 times the square root of 2, which is the square root of 4. I stays as I in the numerator. 54, square root of 54 stays in the numerator. I squared in the denominator, I replace that because anywhere you have I squared, it is equal to negative 1. And then the square root of 4 is 2. So the final answer here would be I square root of 54 all over negative 2. You could also write that with a negative out front. Either of those two answers are equivalent, and they would be the same. Oops, I forgot to record that. So again, just treat I just like a variable unless you see I squared is equal to negative 1. So if you have two pieces that you have to subtract, remember that subtraction sign gets distributed to both of those. And then when you're writing the number, the complex number, the real part should always be first. So this is just going to be 8 minus 2, which is 6. And then I'm combining my imaginary part, which is negative 1 plus 3i, which just gives me my plus 2i. And that's it. That's all you'd be doing with this. Multiplication works exactly the same. So when you multiply, it could be negative 2i times 5i. Now remember, this is where you follow the rules until the very end. So this becomes negative 10i squared. But that's not going to be a correct final answer because you have to take that last step and turn that I squared into a negative 1. So negative 10 times negative 1 is just a positive 10. And you know nothing would be complete unless we factor or have to FOIL. So if you had 3 minus 2i quantity squared, remember this 2 on the outside means you have to write this twice and then FOIL. So it would be 3 minus 2i times 3 minus 2i. And again, be really careful whenever you have imaginary numbers. I squared is not allowed. You have to change it. So first I'm going to go ahead and multiply this 3 times 3, and then 3 times negative 2i. When I do that, I just get 9 minus 6i. I distribute the negative 2 times 3 and negative 2 times negative 2i. So that's going to give me negative 6i. A negative 2 times a negative 2 gives me a positive 2. So that's going to be positive 2. I times I is I squared. But again, be very careful. I have to go through and combine like terms. So I'm going to go ahead and combine those because they're both i's. And that, yes, thank you. That's, yeah, that, wow. Negative 2 times negative 2 is a positive 4. So thank you guys. So then I go through and just make that 9 minus 12i. That doesn't change. When I'm adding variables together, you don't change their power. But over here, that becomes a positive 4 times a negative 1. So now it's 9 minus 12i minus 4. You have to go through, and 9 minus 4 gives me 5 minus 12i. So be careful that you always make sure you include that I is equal to the negative 1.